Okay, now we have created our 6 ties, if you will. Again, what we do here is we create ties between our image and our reference. And what we can see here, this is our information about that. And what you'll notice, I have 6 links: my X source, my Y source, my map coordinates for each one. And then you'll notice the residual here. Okay, and again, that means, in a sense, how much is left over that they couldn't pull together for each of these. Now, one of the interesting things is this is where we begin to talk about transformations. First order, or affine transformation, doesn't allow us to make these, in a sense, work together. In other words, if I only stretch within certain limits, I can't quite get them together. But if I change this to a second order polynomial, you'll notice that, in fact, by certain types of warpage with these 6, I can do quite well. I get these things to tie together quite tightly. And so then my residuals become, and it's not really quite 0, but it's very close. And in fact, if I now begin to look at these, we're in really pretty good shape. So I'm going to zoom in. You'll notice that one very nicely there. And so we want to think about what is, based on our points, what is our most appropriate transformation. And so now we have a second order polynomial transformation. We've got our tie points. Everything seems to be in good shape. And so now it's, relatively speaking, straightforward to, again, rectify the image. And that means to actually recreate an image using those tie points and producing the new raster data set. Always remember, you are in control of what order polynomial transformation to use, and different ones require different numbers of control points. You'll notice, for example, that I would have to have at least 10 control points, evenly spaced, to do a high order, third order polynomial transformation. That's really the highest order that ARC is going to do. You can, of course, do an adjust, and that's a very simple adjustment transformation. Again, only 3 points. It is also possible to do, for example, let's just grab the projective transformation here. And you'll notice that when I do the projective transformation, we lose some of the quality. Again, going back to here, you'll notice that our residuals are quite high. And so we want to kind of work through these and see what the implications are for each of these. Again, look at your notes and kind of consider which of these is most appropriate. But for right now, I'm going to do a second order polynomial transformation. Each one of these works, and warpage is occurring in 2 different directions. And once we're done with that, the next step is the rectification. So I'm going to click on rectification, and the cell size, I'm going to let it default. I'm going to use, because this is an image, the resample, and remember, this is where we recreate pixels based on neighboring pixels. I'm going to use a simple bilinear interpolation, and I'm going to write this again to our I drive. Okay, in my case, I want to write to the I drive. You're going to do this to your file, and I'm going to write it into the imagery file. And again, this is my workspace, so I'm going to set it to the geodatabase, and then I'm going to name it. And in this case, I'm going to simply name it rectify, and I'm going to put second order, and no compression type, and I'm going to click Save. All right, while this is running, we will see that, in fact, when we come back to the next video, what the resulting image looks like. So until then, Good luck.